Today's lesson is brought to you by Walmart. We are the only store open. So what are you waiting for? We have hand sanitizer and toilet paper in a bountiful supply. All right, welcome back to math now. Hope you guys are having a good day here. And hope you're set to do the retry of the test. Unless you're happy with your grade, but I think a lot of you guys are probably going to want to retry it, and that's okay. I know this is difficult stuff, especially because it's virtual on here, but some of you guys need to, get out of your hibernation mode and ask me some questions. It's like you're on another planet and you're not talking to me at all. Why don't you, send me an email, say that you're doing well sometime. I'd like that, to hear from you guys. Anyhow, on to your test here. We're going to do a quick review. The first problem, I'm not going to go over because it's pretty straightforward. If you know what similar figures are, you can figure out the answer. Similar figures have the angles that are in the same position being the same, and the ratios of corresponding sides being proportional. Okay, corresponding is a fancy way of saying in the same spot. Okay, so given these two triangles, okay, I drew them out already, which of the following must be true? Okay, so remember it has to be most likely one of these two things. All right, there is one little tricky thing here though, and that is this letter B here. You're comparing the ratios of the angles. So let's think about this for a second. Angle B, okay, angle P and angle X are in the same spot. Okay, so that means that they have the same degree measurement. Okay, and if they have the same degree measurement, if you divide them, their ratio is 1. Okay, likewise, Q and Y are in the same spot, so they have the same degree measurement, and if you divide them, their ratio is 1. Okay, so this is actually a true statement here, even though it's not like one of these two things that is true about all similar figures. All right. Remember, the sides aren't equal in similar figures. Okay, in congruent figures they are, but not in similar figures. So hopefully you can figure out these ones. Just remember you're matching up, like for letter A, you're matching up the ratios. Okay, and is this true? Okay, you have to think, is it true for one of these two questions? All right, let's go on to the next one here. So what condition would prove that these two triangles are similar? So remember, to prove triangles are similar, it could be angle-angle similarity, side-angle-side, or side-side-side similarity. Remember, for the sides, they are not equal. They are in proportion, so they will have the same ratio. All right, so let's redraw the triangle so that they're facing the same direction. So if you're not sure how to redraw the triangles, look how the letters go. DE. Okay, DE goes with JK. So I'm going to take this J and match it up with the D. And you see how E is next? That means that K, okay, is matching up with E. JK, DE. All right, so you always got to look at the order of the letters when you're redrawing it. So JKL looks like this, basically. Okay, I did not do a great job of redrawing that, but you get the idea here. So the angle D matches up. Oops, I wrote DKL here. It should be JKL. So let me squiggle that out there. All right, so this is a J. That's a JKL. All right, and we know that KJ, okay, is equal to 7. Okay, and it matches up with DE. So here, these choices are all talking about the ratios. A colon here means the ratio. So you're comparing DE, the ratio of DE to JK. All right. So in order for this to be similar, okay, we cannot use angle-angle because we only have one angle. So we're not using that. And we only currently have one side pair and one angle. Okay, now since we have a side pair and an angle, all these choices only give you one more side pair ratio. So you're not using side, side, side. So you're using side, angle, side. You want to pick which side would give you side, angle, side. Okay, And that is not EF. Okay, EF would give you side-side angle. So you want to pick the side that will have this angle in between it. So that would be DF compared to JL. Okay, so this ratio isn't the one that we want. This ratio is actually already given to you, okay, in the problem. So it's not the one that we want. The one that is given to us in the problem is the ratio of 21 to 7 if we go from big to small. Okay, so by the way, over here they're going from big to small. Okay, so you're doing big to small ratios in this problem. DE to JK. Big to small, I mean big triangle to small triangle, in case you didn't quite catch that. So that is the ratio of 3 to 1, or just 3 if you reduce it. All right, so the first two choices are off the table there. All right, and so you want to pick the answer that will give you side angle side, which would be DF compared to JL. All right, let's look at this next one here. Okay, this one's a little bit tricky here. We're trying to figure out VW. All right, so you have two triangles. One's inside of the bigger one. Okay, so you have the bigger one to focus on and the little one. Okay, so VW we don't know, so I'm going to call that, we'll just call it mysterious letter. We already have X used, so I'm going to call that B. Okay, I'm going to call that letter B. Okay, so VW for simplicity, I'm going to call B. And it's actually in both the little triangle and the big triangle. All right, so when we figure out B, we figure out VW. So first we need to figure out something else about this little triangle so that we can set up a proportion here. So we know that these are similar because it's angle-angle similarity, because they're both sharing angle V and they both have right angles. Okay, it's not told to you in the problem, but it's kind of assuming that you would think that. So we have to figure out VZ. VZ is going to be 16.5. You might be wondering how I got that. It's not from thin air. Okay, 44 is this across. So if you subtract 27.5, you get VZ, which is 16.5. All right, so now that we have that, we can actually write a proportion to figure out B. Okay, so all right, let's start with writing B. Okay, B is the hypotenuse of the little figure. The hypotenuse of the big figure is not B, it's not 36, it's a combination of B plus 36. Okay? Okay, we set that equal to, let's go to the little figure, it's 16.5. Boom. Okay, compare that to the big figure's base, which is 44. Alrighty, and then you need to solve this by cross multiplying. So you're going to do 44 times B, so that is 44B. And on the other side, you're taking 16.5 and you're multiplying it by the quantity. Okay, group this in parentheses, B plus 36. All right, oops, try that again, B plus 36. All right, I am sorry, my 6's kind of look like B's. It's very difficult to write with this mouse. All right, so that's 36 there. So you just have to solve this equation now, okay? So you're going to distribute to both sides. So you have 16.5B, okay, 16.5 times VW, and then you have 36 times 16.5, which is 594. You have 44B, okay? And then you want to isolate the B term and then divide to get your answer there. All right, let's go to another one here. This one, what is JL? Okay, so JL is this whole entire base here, okay? Now, we know JM. In fact, if we figure out LM, it's going to make it easier for us to figure out JL. Okay, so we need to figure out LM in order to figure out JL. Okay, so these triangles are not drawn the same way. Okay, This altitude here is going to form similar triangles. That's the whole point of lesson 7.4. The altitude forms similar triangles. So what we're going to do is redraw the triangles so that they are facing the same direction. Okay? Boom. Magic. So what I basically did is I took this triangle here and I rotated it like that. Okay? So that is now facing the same direction as the other one. Alright, so the 12 is the shorter side in the medium size KMJ triangle, but it's actually the second largest size in the smallest triangle. LM's the shortest side of all the triangles here. Okay, so now we need to figure out LM. Once we figure out LM, we can figure out JL. Okay, remember JL is LM plus the one that they give us, which is MJ. Okay, LM plus MJ. Okay, so write a proportion now to figure this out here. Okay, so we're looking for ML, so I'm going to start with that. ML gets compared to KM, okay, because they're orientated the same way, and KM is equal to 12. Then we went from small to big, so we got to do MK, which is 12, okay. MK is in both triangles, by the way, and it's getting compared to MJ, which is equal to 16. All right. So you do cross multiplying. 12 times 12 is 144. 16 times ML, and we divide by 16. Take 144 divided by 16. Some number. I messed it up in the calculator. Bear with me here. It's 9. Okay, so ML, like I said, is going to be the smallest of all the sides, and it makes sense. Our answer there is 9. Now we're looking for JL, so you have to add 9 plus 16. So JL is equal to 25. All right, remember JL is LM plus MJ. All right, let's try to do this one right here. So in this particular one, to figure out the altitude's the geometric mean, okay, of the two parts of the hypotenuse. All right, so in other words, what we can do to figure out the altitude is go like this. We could have x over 4 is equal to 16 over x. All right, so, and then the geometric mean means you multiply together the two parts of the hypotenuse. So it'd be 16 times 4. And you have x times x, which is x squared. All right, and then you just need to reduce this. 16 times 4 is equal to 64. So our altitude is equal to 8. All right, so this is all in that 7.4 lesson. So if you're not so great with that, look back at the 7.4 lesson here. But anytime you're finding the altitude, it is the geometric mean. Geometric mean means you multiply the two parts together. Okay, and then you take the square root of it. All right, let's look at this one here, which are similar to triangle JKL. Okay, so the order matters here, JKL. So the short triangle here, okay, remember JKL, this one you have to rotate it, okay? So for the smallest triangle, it would be L to K to M. So like this middle part here becomes the new base if you rotate it, okay? And then you would also, this would be yes, this is true. One of the things that you should look for is if the right angle is in the middle, like JKL, you see the right angle is in the middle, K. All right, so JLM, you see the right angle's in the middle, okay? And it's also going from the medium side to the smallest side to the hypotenuse. So yes, this one is also true. But look at the last one, KML. Okay, KML, M isn't the right angle. Okay, remember the middle angle is the right angle, but not in this one. So no, this one is false. All right, well, that's about it. I'm sorry I rushed through that a little bit. The problems can be rather lengthy, but hopefully with the bonus quiz and then the quiz retry, you guys will be all right. And we're just going to move on to the next lesson on Monday. Have a great weekend. Take care, guys. Bye-bye.